I redid one of the assignments I had a 2 out of 5 on.
You redid the whole thing, or you just did the stuff
No,
that
I redid the whole thing.
fixed it? All right.
So
All right, cool.
Yep,
Go ahead and slap that in there too.
All right.
I'll probably get it here in the next day or two.
Well, that's
snap.
neat too.
What's that?
That little thing
What thing?
on the thing that we did.
That thing?
Yeah.
What'd you think?
I think it's actually pretty good.
Yeah?
Saves time.
It saves time.
Yeah,
Definitely. Well, I think there's going to be more videos, but the videos are going to be shorter. I think that's how it's going to shake out. But that's part of why we're doing it too.
Fast.
What's that?
This was a little too fast.
Well, that's why you use the pause, right?
Yeah.
Just use that pause button.
Hi, dislike?
Yes, sir. Thank you.
Alright. Bye.
Bye. How goes it? Good. Is that your knee surgery right there? Dude, that's a heck of a scar right there. That is awesome. I got see if I can check this out. So I got this on each knee. I did I don't know why. You can barely see it, but I got a scar right there, and then I got itty bitty scars like right here and stuff. So did you have an ACL done?
No.
What'd you have?
EFL, and part of my kneecap chipped off, so there's a screw attached.
What did you do?
I dislocated my knee.
That's like, ow. So do you follow football at all?
I mean,
Even a little bit?
yeah.
Remember when Teddy Bridgewater got hurt?
No. So yes. I mean, yeah.
So Teddy Bridgewater was a Vikings quarterback from a few years back, and he dislocated his knee. They came this close to amputating that thing.
Actually, I do remember that.
Yeah.
Real.
Yeah.
Yeah.
Was it that bad? Where they talked about possibly amputating your leg? No? Okay.
No, I just have a lot of scars because I had surgery on it again.
Right. I remember that. I remember that well. But I had surgery on this one twice,
Yeah.
and you can hardly tell. All right. All right. Oy. No. We're going to do some, technically a work day, but I figured I'd do some problems out of the book that are similar to the practice set, so that y'all know what's expected of you. You guys seem to like it when I do that. So that's what I'm doing. I'm going to do 4 problems in class today. What's up with you? What's up with you, yo? We're doing 11.3, right?
Where'd your charging thing go? Station.
Oh, the charging station's gone, but you got the cord. Unplug the brick right there and plug your thing in. All right. So we're doing calligraphy pen. We're doing 3, 11, 13, and 65. All right. We're doing these exercises together today. Hopefully these will give us motivation for how to do the homework, which I'm making due on Friday, by the way.
Thank you. So no test?
No test tomorrow, no quiz tomorrow, it'll be on Friday. Logan's here, AJ's not. Is Josh here? Yes, he is. Mason's here, Alex is here, Kaylee's here. Spencer's not. Hannah's here. Kristen is. And Hallie is. All right. And then who am I missing for? All right. And Spencer's of them. All right. Good. Good. So everybody should have their notebook, their calculator, their workbook, their textbook, because we're going to go into exercise examples today. We're going to do exercise examples today. I figured we could do 4 problems together, which should give you motivation on how to do the remaining problems out of the problem set. I posted that to Google Classroom today. It is due on Friday, vice Thursday. Okay? Due on Friday, vice Thursday. We will do workday tomorrow, Friday, due, and quiz. Okay? Now, do I have any seniors that will not be here on Friday? You will not be here on Friday? You will not be here on Friday, but not because you are a senior.
I'm just trying to see if you.
Where's the NHS field trip?
Okay. Are there other people that are not NHS that are in that field trip?
No.
It's just NHS, huh? Okay.
It's our service project.
Okay. All right. So, who wants to go through these with me? Is that a yes, or is that I have another question? Thank you for participating in my questionnaire. I appreciate it.
Okay, is this on?
This is on 808. We're on page 808. Isn't that just wicked awesome? All right, so my function looks something like this. It is -1, 1, -1, and it does something like this. It goes through like that, right? And then I'm going to make my tangent line green. And actually, I'm going to make my thing a little not as steep. And then I'll do, there's my tangent line. Isn't that a great tangent line right there? Isn't it a great tangent line? Know the right answer when told, Alex. Right? All right, so it's a great tangent line. Okay, so what do I know about this point right here? Now, before I go on doing anything, I should probably read the directions for this problem, right, Zach? Yeah. What is the directions? It says, in exercises 1 through 4, use the figure to approximate the slope of the curve at point x, y. And this is x, y. Now, when they say the slope of the curve, do they mean the straight line or do they mean the red line? Am I approximating the slope of the red line at point x, y? Or am I approximating the slope of the green line at point x, y? Yeah, I'm doing the red. I'm approximating the slope of this guy by calculating the slope of this guy. Why am I using this guy to calculate the slope? It's a tangent of this function. At least we think it is, right? It looks like it meets the criteria of a tangent. And what is the criteria of a tangent? Yeah, it touches at one and only one point, right? Good. And this looks like it meets that criteria, so we're going to use it. Now, what do I know about this point? And forgive my artwork's awful, so look at the picture in your book. Logan, do you need to go get your book?
Yeah.
Go get your book. Oh, 808. So what's that point right there? It says XY in the book, but can I tell what that point is? What's it? 1, 0, right? X then Y. This is 1, comma 0. Okay. And then what other point should I use for the line? Because I'm calculating the slope of the green line to estimate the slope of my red curve, right? At that point of tangency. So what other point should I use? The y-intercept. Great. And again, don't look at my janky drawing. Look at your drawing in the book for number 3. What would you say the coordinates of that point are? Yeah, except point is an ordered pair, right? So, yeah, there you go. 0, comma, negative 0.5. And when I look at the graph in the book, I see the same thing. Okay, now, can I calculate the slope of my green line? How do I do that? M equals... Yeah, it does. I give you that. I want to go all the way to the beginning. Slope is rise over run, which is my change in y over my change in x. And now, Spencer, you said y1 minus y2 and x1 minus x2. X. All right. What is my y1? What do I want to use as my y1? You want to use that is my negative 0.5 is my y1. So negative 0.5 minus what? That's y1, then y2 is 0. This guy, right? And then x2 or x1 is 0, right? This guy. Minus 1. Which equals negative 0.5 minus 0 is negative 0.5. 0 minus 1 is negative 1, which equals what? Positive 0.5, right? Or positive 1/2. I will take either either answer. Either answer. Okay? That's number 3. That should give you an idea as to how to do numbers 2 and 4. All right? The next one I decided we do together is number 11. Now, the good idea to do before we go anywhere is to read the directions for problems 5 through 12. And it says, use the limit process to find the slope of the graph of the function at the specified point. Use the graphing utility to confirm your result. Okay? So, my function is f of x equals the square root of x, and I want to evaluate this at 9, 3. Okay? So I want to find the slope of this curve at this point on the curve. Okay? Now, is this point on my curve? So in other words, when x equals 9, is f of x equal to 3? I agree. So first test, tested out, sat, right? Second test, how do I use the limit process to determine the slope at, what point do I want to determine the slope at? At x equals what? At x equals 9, right? So, what do I do? What's that? I call it the difference. Remember this? Come on, guys. difference over h. What did we call this? What's this part called? It's a numerator, but I'm not looking for that. This makes it a what? Difference. And this part makes it a what? Quotient. Difference quotient. Do we remember that term? This is the difference quotient. Except I don't want x to be x here. What do I want x to be? I want x to be 9. So let's fix that. Let's fix that right now. Changing all my x's to 9s. All right? And what do I want to do to this difference quotient? I want to analyze what? The limit as what, Zach? Nice. Zach is on point today. Okay, so now I do f of 9 plus h. What is f of 9 plus h?
9 plus h square root.
Yeah, square root of 9 plus h, right? So this is the limit as h approaches 0 of the square root of 9 plus h minus f of 9. What's f of 9? You can either figure it out or you can realize that they gave you the answer, right? Where's the answer?
Right there.
Right there, right? Minus 3 all over, not over 2a. We're not in quadratic formula. Silly. Now,
Like a
how do I figure? Can I use the direct substitution right now? No, it breaks 0 breaks my denominator, right? Yeah. Good use of vocabulary. I like that. So how do I rationalize this?
with the 9 and the 8.
9 plus h plus 3.
Yeah. So the numerator gets square root of 9 plus h plus 3. But Alex said, he's trying to be cheeky, but what's the value of that fraction have to be? 1. So what's the denominator have to be? Plus 3. Good. Good. Now, when I multiply this out, first times first, I get, let me do my, I'm tempted to leave this out. And can I leave that out yet? No. I think you guys got that part, huh? So when I multiply first times first, I get what? 9 plus h. Outer times outer? Three root 9 plus h, right? And then inners minus 3 root 9 plus h. That looks like 9th, doesn't it? Let's fix that. The top one. You mean this one? All of them? Ah. And then what? Last times last minus 9. Okay. And then over. Now I'm going to multiply these out, but I'm going to leave it in factored form. I'm going to leave in factored form. Why do you think I'm going to leave in factored form, Logan? Yeah, if I multiply this out, I might just have to factor it again later. Okay? Can I simplify? What goes away? 9 goes away with negative 9. Negative 3 root 9 plus h goes away with positive 3 root 9 plus h. And what's that leave me in the top? H. which goes away with this h and leaves what in my numerator?
1.
Okay, so I got 1 over that hot mess, right? Can I do direct substitution at this time? Really? I still got 9 plus 0. Square root of 9 plus 0? 3, right? Let's do it. Let's make sure. I'm going to give myself some more room. Okay? So this is the limit as h approaches 0 of 1 over root 9 plus h, all plus 3. And now if I do direct substitution, I get 1 over root 9 plus, what am I substituting in for h?
0.
Plus 0 plus 3. Notice my limit notation is gone now, right? I can lose the limit notation when I direct substitute. But this is 1 over, what's the square root of 9?
3.
Why not that? Ah! Why is that important, Kaylee? And we assume what?
Positive.
We assume the positive of the square root when it's in function notation, right? Yeah. Okay, so this is only positive 3. This is only positive 3. So let's get rid of this plus or minus business. Okay? And now, 1/6. 1/6 is my slope. Look at that, we did that right. Well, that's because we were doing the slow approach, right? We were talking about every step as we did it. That's why it took long. Now, for numbers 13 through 18, and this is g of x equals 4 minus x squared. It says, 1, they want you to find the formula for the slope of the graph of f at the point x comma f of x. Can we put that into language that we've used or that we've discovered? What do they want me to find? They say a formula for the slope. What did we do yesterday? We figured out how to find what? Starts with a D. The derivative. What is the derivative? It's a function, right? They call it a formula, right? But this is a special kind of formula called a function. And that function does what? Gives me a slope of another function, right? Okay. So they want me to find the derivative of g of x. What do I call the derivative of g of x? G prime of x. And if I use the power rule, what would my g of x, g prime of x be? Who remembers the power rule? Power times the coefficient gets me what? Negative 2, right? That's plus a negative 1 times x, right? So that's negative 2, and then the power goes down by 1, right? And then I'm done, right? Once I'm done with x's, I'm done, right? So this should be my derivative. That should be my derivative of g. So now, let's do the same thing we did here, except instead of putting 9 in, we're just going to leave it an x, right? So what's my difference quotient for g of x? Instead of f, it's going to be g of what? X plus h. Minus what, Hallie? I'm building my difference quotient. G of x all over, And then I missed something, didn't I? Bingo. Limit as h approaches 0 of that business. Now, G is a list of directions that tells me to do something to X. What am I doing to X?
Plus H.
No, what am I doing to X right up here?
Square.
I'm squaring it, and then I am subtracting that from 4, right? Oh, I hope you don't do that to me. Now, I'm not doing g of x anymore. I'm doing g of x plus h. So what do I do with x plus h? I square it, and then I subtract it from 4, right? So now I got the limit as h approaches 0 of 4 minus x plus h quantity squared minus 4 minus x squared all over h. Okay? Now we should be able to make some sense out of this, right? So let's do some polynomial math. Let's write some stuff down and do some polynomial math. And I will bring my limit notation down because we are not done with him yet. I got 4 minus the quantity. I'll leave that for yins. And then I'm going to distribute that negative, so that becomes plus a negative 4, and then plus x squared. And that's all over h. And while I was doing that, y'all should have gotten me a value to put in the, or an expression rather, to put in the parentheses. X squared plus 2xh. Nice. Okay.
Boom, boom.
Yeah, boom, 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 right? Boom, 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 boom. Now what can I do? Yeah, I can get rid of things, right? What can I get rid of? 4s. Let's get rid of the 4s. Whap out. X squared.
Back Pete's lost.
Did Pete get lost?
I don't like him looking at me.
Sorry. I'll edit that out. So now I got the limit as h approaches 0. Did he get lost again? No. Of negative 2xh minus h squared over h. What can I do, Logan? Logan Nelson in the back. Factor out an h up top and then cancel out h's. Let's do that in 2 steps. The limit as h approaches 0 of h times, what am I doing up here?
Minus h. Let's do it in 1.
And then cancel, right? Now I got the limit as h approaches 0 of negative 2x minus h. Can I direct substitute now? So this equals negative 2x minus 0 extend page. So then g prime of x, can I simplify this term? What is that? Negative 2x. And is that what I predicted my answer to be? Yes, it is. Okay, so that is the derivative. Then it wants me to find the slope of g at the point 0, 4. What do I do? Plug in what? 0. Plug 0 in, right. So G prime of 0 equals negative 2 times 0, which equals 0. That's letter A. Letter B, and I think this was G of negative 1 comma 3. What do I plug into G prime? Negative 1, because that's my x value, right? G prime of negative 1 equals negative 2 times negative 1, which equals 2. Now, let me ask you something. This point right here, where the slope equals 0, what kind of function was I talking about way up here? What is G? What kind of function? Yes, quadratic. What's special about the slope at x equals 0? It's, what do we call that bottom or the top of the parabola? Vertex, right. Right, good. Good. Good intuition, good knowledge of the definitions. Excellent. Okay. That's 13. 65. 65 is a word problem, and it's entitled Rate of Change. It says a spherical balloon is inflated. The volume, which they call V, is approximated by the formula V of R. Why'd they choose V? Volume. Why'd they choose R? Radius. Radius. Because the formula is V of R equals 4/3 pi R cubed. And what's R? Radius of the balloon, right? Now it asks me to find the derivative of V with respect to R. So what should my difference quotient look like? Instead of F and instead of G, it should be what? B. B of what? R plus H, right? Minus what? V of R over H. Am I done? What's missing, Zach? Limit notation. The limit as H approaches 0. Now, to do this, how do I do that? Let's do, I'm going to show you a trick that's going to make your life so much easier with problems like this. Okay? You got to get the limit as H approaches 0 of, this is 4/3 pi times R plus H cubed, right? Minus 4/3 pi R cubed. All over H. What does this term and this term have in common? 4/3 pi. Let's factor that out so we don't have to worry about it until later. The limit as H approaches 0 of 4/3 pi times R plus H cubed minus R cubed over H. I can bring this guy out here if I want to, can't I? Remember that from our limit properties? Yeah. We're not going to do it right now because this will get easier in a minute. What's the elephant in the room right now? The cubed part, right? This was square to be easy day, right? But it's cubed.
Can we do like a property since it both?
What's that?
Can we do like a property since it both
You have to cube it out. But I got a trick for you. It's called the binomial theorem. Anybody ever heard of the binomial theorem? The binomial theorem says this is r cubed plus 3r squared h plus 3rh squared plus h cubed. Sorry. Minus r cubed. Now, this guy, I got that via the binomial theorem. Okay? You don't need to know it, but you want to know how it works? YouTube, Google Pascal's triangle. Pascal's triangle. And it'll blow your mind. It's easy and it's profound. You will like it. Look at that. All right. And that's all over. Did I just hear I hate this class?
All over to
Oh, no, not all over 2A. Get 2A out of your head. All right, now what? Cancel out the r cubes, right? Can I cancel anything else out? No, but here's what I'm going to do. Everything else has got an h, right? Everything else, I'm going to factor that h out. Now, if I factor an h out, this h goes away, right? This h goes bye-bye. What about this h? It's just one of them. And this h? Two of them. So that becomes a squared. Okay? These h's go away, yes?
Yeah.
Now I got 4/3 times 3r squared plus 3rh plus h squared. Can I do direct substitution?
Yeah.
All right, and that equals what? It equals 4/3 pi times the quantity 3r squared plus what happens to the 3rh when I put 0 in for h? It goes bye-bye, right? What happens to the h squared that goes bye-bye too. So it's just 4/3 pi times 3r squared. 3's cancel, and I get 4 pi r squared. And then it asks, this is part A, v prime of r, right? Part B is, what's the value of the slope at r equals 4? What do I do? Plug in 4 for r, and bam, you got your answer. All right, ladies and gentlemen, remember, work day tomorrow. Assignments due, quiz due on Friday. Kaylee, what are we doing? Do you want to do early or do you want to do Monday? I got a couple other students doing Monday.
I'll do Monday.
You'll do Monday?
Yeah.
All right.